Good morning, everybody. It's Wednesday, September 23rd. Today we're going to talk about right triangle trig. So this is the 7.5.1 notes because we'll have 2 days of it. Today is going to go through the notes and then exit ticket, and then tomorrow will be a practice day. So let's start out here today with a warm-up. So this is a application problem of why you might want to be able to use trig in a real-life problem, right? So it states here, you just bought a building to begin your own restaurant business and want to be inclusive of all customers, including those who are handicapped. According to regulations, the ramp cannot be higher than a 5-degree slope. If the front door is 2 feet higher than the sidewalk, how long will the ramp be? So I want you to pause the video, kind of take a look at it, see if you can figure out how to solve this problem, or maybe potentially what steps you might take to do so. In the meantime, I'm going to draw this picture here for you, and that represents the triangle that you would see with this ramp. So if this is the ramp and this is the top of the sidewalk, it says that that is 2 feet higher. Okay, so that's 2 feet. And then this is a 5-degree slope. Okay, obviously that looks a lot bigger than 5-degree slope. So then it says, how long will the ramp be? So it wants to know how long is this part. Okay. So think about that, see if you can figure it out, pause the video, we're going to come back to it later. Alright, so trigonometric ratio. What are trig ratios? Trig ratio is a ratio of the length of two sides of a right triangle. The hypotenuse of a triangle is always the same, but the terms adjacent and opposite depend on the angle being referenced. So why is that important? Well, because when we are talking about a triangle, okay, like a right triangle, we want to use SOHCAHTOA or trig. Okay, usually you have you always have a 90-degree angle, and then you'll have an angle that they want referenced, okay? Now, if they choose this angle, you can see that across from this, all right, we would call that opposite. All right, and then so the side that is not the hypotenuse, because the hypotenuse, remember, is always across. I guess I could use my new feature, huh? The side that is the hypotenuse is always across from the right angle. So the side that is closest to that angle, and you can see here it kind of looks like an Easter egg, but that's called theta. So it's Greek. But that often represents what angle they're talking about. So this would be the side that's closest to it, so we would call it adjacent. Okay, we would call that adjacent. Now, that would switch if we move this around, because now, if that angle is up there, now this opposite would be opposite of that, and then the adjacent would be up here. Okay, so it just depends on which angle they're referencing. They never reference the right angle because we always know what the right angle is. We know that this is 90 degrees. So they're only ever going to talk about this angle or this angle. All right, so how do we solve when we have a problem like we did up here? Well, we're going to use sine, cosine, and tangent. So sine is opposite over hypotenuse. So it's a ratio where you take the length of the opposite side and divide it by the length of the hypotenuse side. Same thing with cosine, only it's going to be adjacent over hypotenuse. Okay, and lastly, tangent is a little bit different. You can see that the only difference between sine and cosine is an opposite and adjacent, whereas tangent is opposite over adjacent. Okay, so it does not use the hypotenuse at all. All right, so what many people reference is SOHCAHTOA, because as you can see, it has sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so if you remember this phrase, SOHCAHTOA, SOHCAHTOA, okay, you will be able to remember the trig functions a little bit easier. All right, so what we're going to do is go through some examples. It says, using the triangle to the right, complete the following trig ratios. So angle A, all right, so this is angle A right here. angle A, we want to know what is sine of A. So I'm going to look at A, and remember that sine is SOH, S-O-H, so it's opposite. So opposite is little a, okay? And then hypotenuse is C. I deleted, I'm just realizing I did not have the right triangle listed. So I'm going to give you one here. I'm going to give you one. Let's say that this side is 5, this side is 12, and this side is 13. I messed up on that one, and I think I accidentally deleted the correct one out. Okay, so angle A, sine of A. Oh, I knew what I was doing. We're just going to use letters. Let's just use the letters. So sine of A is opposite. So A over the hypotenuse, which is little c. Okay. Cosine is adjacent over hypotenuse. So adjacent to A, that's the closest side. So here's A. The closest side is B. And the hypotenuse is still C. Okay. Then tangent of A is the adjacent over the or the opposite over adjacent, which of course I got wrong. I meant to put A over B. Okay, so now let's try angle B. Let's try angle B. So angle B, sine is opposite over hypotenuse, so B over C. Cosine is adjacent, which would be A over C. And again, I'm looking up here. So adjacent to B is angle A, or is side A, and then hypotenuse C. And then tangent of B, so tangent is opposite, which is this, over adjacent, which is that. So B over A. Okay? And then angle C, so here's what's tough about angle C is, if I go to put sine of C, okay, sine is opposite. Well, what's opposite of C? Well, that's C. And so is the hypotenuse. So that would just be 1, right? How about cosine of C? Well, cosine is adjacent. Well, is that going to be A or is that going to be B? Okay. Could be either one. And then tangent is opposite over adjacent. So that's either C over A or C over B, right? So that's why they don't really reference this angle. Okay, because it's kind of undefined in some parts because we have two different options and we don't know what option it is. Okay. All right. So now I want you to go ahead and pause it, give this one a shot, and once you're done, go ahead and play the video. Okay. So now that hopefully you've paused, I'm going to actually give you the answers here. So angle A, sine of A, is opposite over hypotenuse. So if this is A, right, opposite is 3 over 5. Cosine of A is adjacent over hypotenuse. Adjacent side this time would be 4. And then tangent of A is opposite over adjacent. Okay, let's do the same thing with angle B here. So angle B is up here. Sine of B is opposite over hypotenuse, cosine of B, adjacent over hypotenuse, and then tangent of B is opposite over adjacent. Okay, and then angle C we won't do. Okay, so another example here that we have, finding trig ratios from similar triangles. When you have two similar triangles, like this here, it says triangle XWZ is similar to triangle ABC. When two triangles are similar, their blank are congruent, and the sides have this blank ratio. So if you remember, this is what we talked about when we were talking about 30-69 or similar triangles, where we used angle, 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 side, angle, side, or side, side, side. Okay, so this is the same thing. So in order for a triangle to be similar, they have two properties. Their angles are all congruent. That's where this comes into play. Or all their sides have the same ratio. That's why we set up those proportions before. So in this example, if sine of y is equal to radical 2, okay, so y is here. So if we said sine of y is equal to radical 2, well, if this is a similar triangle and we're saying that b is similar, then it should be the exact same answer, right? It should be the exact same ratio. So given that these triangles are similar, and sine of z, so this is z, sine is opposite, so opposite over hypotenuse, is radical 2 over 2, so this would be opposite over hypotenuse. It says find what is sine of c. Okay, so we're going to change these out. So opposite would be radical 2, this would be 2. Okay, it says what is sine of c? Well, since z and c are the same, it should also be radical 2 over 2. What is cosine of c? So cosine would be this adjacent, right? Well, think about this. What triangle do we have that we could use for this? Well, you could set up Pythagorean theorem since you know 2 of the sides. Radical 2 squared is just 2. Okay, subtract 2, x squared equals 2. Then take the square roots, x is radical 2. So this would also be radical 2. So we have 2 sides that are exactly the same, right? So cosine of c would also be radical 2 over 2. So since the sine and cosine are the exact same, okay, we have a 45, 45, 90 triangle. Okay, so we talked about that the other day. All right, so find sine, cosine, and tangent for a given angle in the calculator. This is the last thing. So sometimes they're actually already going to give you the angle, and all you have to do is plug it into your calculator. So we're going to do that real quick, and I will show you how to do that. If you are using Desmos, the only thing that you have to do is make sure that it is in degrees and not radians. So we're going to go up in settings, and right down here on the bottom it says degrees or radians. We're going to change that to degrees, and then we're going to plug in our function by hitting the functions in the top right here, and then you're going to look up and say tangent of 35. I think that was it, right? Yeah, tangent of 35, and the answer was 0.7. Okay, tangent of 85, and then tangent of 10. Functions, tangent 85, 11.43. Functions, tangent 10. So 11.43. Tangent of 10 is 0.176. 0.176. Okay, so if they give you the angle, you can just type it into your calculator, and then it gives you the ratio. All right, so you have a couple practice problems where you're going to use SOHCAHTOA to solve for the missing side length. Okay, you're just going to basically write the proportion that it would be. And then you have an exit ticket at the bottom as well. So, for instance, in the first one, you have to figure out, okay, here's my angle. What side is this? And what side is this? Well, this side is opposite, so we would use sine, although they also have an x here, and that's the adjacent, so we're going to use tangent. So tangent of 22 equals 3 over x. Okay, so we want to solve for x. So I'm just going to show you how to do this. We're basically going to take 1, cross multiply. Okay, so I have 3 equals x times tangent of 22. Tangent of 22 is a number, right? Like if you look up here, we'd get a decimal. Okay, and now I'm going to divide to get x by itself by tangent of 22. You could have also already calculated it at this point. Okay, so I'm going to go into Desmos. So 3 divided by function tan of 22. Okay, 7.425. So x is 7.425. Okay, same thing here. We have 32 degrees. We want to know what is A, what is B. Well, A is opposite. C is hypotenuse. So opposite over hypotenuse is sine. So we have A over 10. Okay, we want to get A by itself. So we are going to multiply both sides by 10. That cancels out here. So I have 10 times sine of 32 equals A. And we're going to plug that in. Function. Let me put a 10 out front though. 10 times sine of 32 gives me 5.3. So that's how you use trig functions to solve for missing variables. So try these other 3 practice problems and then go ahead and move on to the exit ticket. If you have questions, obviously I'll be available in class as well. Have a great day, guys. I'll see you.